weight and mass. You can kind of think of mass as the amount of stuff there is, and it's a scalar quantity. Just write that down. It's measured in the standard SI unit of kilograms, with a small g, and it is not the same as weight. Do not get confused, do not be fooled, they are not the same thing. Weight is a force. It is therefore a vector, and it is measured in the good old standard SI unit of the Newton. And the term is it's loosely used wrongly in everyday life. When we talk about how much something weighs, what we are really talking about is its mass. Otherwise we would be giving the answer in newtons and taking into consideration the gravitational field strength of the Earth. And that would be rather geeky, and I wouldn't recommend that when you're next asked how much you weigh, that you give the answer in newtons. I warn you, you may not have any friends. Now, weight is dependent on a gravitational field. A gravitational field does not affect the size of the mass. So some things have more mass, I have mass, you have mass, this pen has mass, some people have more mass than others. Rick Waller has a lot of mass, Cheryl Cole has no mass, so, it's all relative. But basically the weight is dependent on the gravitational field. So, for example, my mass is about 55 kilograms, and my weight on Earth is roughly 540-ish newtons. And I can weigh a different amount depending on where I am. On Earth, I will weigh a lot more than I would if I was, say, on the moon, for example. But it wouldn't actually make me any skinnier. And this is because the Earth and the moon have different gravitational field strengths. So if you imagine this is the Earth, now there is an attractive force that is always acting on the Earth. And this is because the Earth has mass. Anything that has mass will have some kind of attractive force. So I have an attractive force, you have an attractive force. It just so happens that the Earth is massive, so that its attractive force is going to be much stronger than mine. So the way I sort of think about it is, if I was next to Brad Pitt, even if he ignored all my love letters and everything else, there would still be an attractive force between us, so because we both have mass. But weight is dependent on the strength of this force. So if there are two objects close to each other, even if this is the smaller object, there will definitely be a force acting towards this one as there is towards this one, and then there is therefore an attractive force between the two. So basically, summarising, when a force is applied to an object, it will accelerate, and this is due to the force. And the size of this acceleration depends on the size of the force and the mass of the object. So I'm sure you're all very familiar with the good old F equals ma, F being force, m being mass, and a being acceleration. Now the only real difference is that in this case the acceleration is replaced by the gravitational field strength, which is given g, and the value for g changes depending on where you are. So different planets have different gravitational fields. So even if the mass of an object is the same, the weight of that object will change depending on which gravitational field is acting upon it. So basically I hope that that's helped you understand the difference between mass and weight. So mass is a scalar quantity, it's the amount of stuff there is, and that mass will experience a force, and depending on that force will be its weight. I hope that helps you. Thank you very much.